This video is all about the formal notation used for Venn diagrams and two-way tables in probability. So in probability, we use these tools called Venn diagrams and two-way tables. These are just tools used to visually display or logically display information in terms of data and probability. To use the formal notation, we need to know a little bit about some language within it. So we have what we call set notation. So this is our set notation. Well, a set, in terms of probability, is a collection of elements. It's a group of elements. So it's a group of things that we're talking about. Elements, events, whatever. So it's a set of elements. Okay, so it could be groups of anything really. For example, it could be numbers, it could be letters, or other objects. Usually though, numbers and letters. The sample space is that entire group of elements as a list usually. So it's the whole sample space, and the set is something that's within it. Sample space has a couple of different ways we can show this in formal notation. So we can just use an S. We can use an omega symbol, so that's the Greek horseshoe looking symbol. We can use a U, a capital U. If there's another symbol that I find a little bit difficult to draw, that's another sort of general symbol. So I'll do my best to draw it. Kind of looks like that. I could be a little bit off, but generally speaking, that's where it looks like. And it's all the possibilities. So it represents all the possibilities in an experiment or probability, event, challenge, data collection, etc. Okay. It has also been referred to as the universal set. Because it has everything in it that we're looking at. So a regular set is just a group within it. The big set is our big sample space, or the universal set. Now in terms of Venn diagrams in the formal notation, all right, so this is an illustration of how the elements are distributed. So it's how are the elements distributed across our probability experiment, okay, or among different events within it. For example, we can have just a single circle Venn diagram. So I don't have a set one yet for that. But if we have our all of our events, we can have a set that is A and a set that is not A. So that A with the line across it is not A. So that's the formal notation there. We can also have A, B, and not A again. Okay, so that's how it's referred to. We also have what we call null or empty sets. This is a set with no elements. So it could be simply, so a set with no elements. And could be symbolized simply by an empty set of braces. Or it could even be a zero with a line through it. Okay, so that's the null or empty set. No elements within that set at all. We have also what we refer to as an intersection. So an intersection is generally where in that Venn diagram we have the overlap. Alright, so this is all elements in groups A and B. So this is the one that is the and question. So it has to be both. And to get that happening, we call that A, then upside down sort of U shape, and the B. So there's our formal notation there. That's the symbol for intersection. Okay, that is our symbol for intersection. Union, the union, it has a different symbol, and this represents or covers elements that can appear in both of those groups, right? In either, so it could be in either A or B. So it's an either or proposition. So again, this is the bit that we're looking for, and this is our symbol. So A with that little U shape, the little U shape, B. Okay, so we've got the upside down U for intersection, the regular way up U for union. So there is some good formal notation for us to use. So again, here's some formal notation, formal notation, formal notation. All in the blue is all our formal notation. Mutually exclusive events. Mutually exclusive events. These are events that cannot have anything in common. So no elements in common. So this could be where we have the two circles and there's no overlap. That's our mutually exclusive event. There's the no overlap there at all. Now this one has a formal notation as well. So it is A intersection B. Okay, we're using that intersection B equals a null set. So there's our formal notation for mutually exclusive events. I'll just add an event there. Okay, so that's mutually exclusive. If it's a complement, complement is sort of a partnering up. Okay, so it's the thing that makes a whole. Essentially, it's the thing that makes it all whole. So rather than it being a mutually exclusive thing, it's more like the one before where we had our group that was A and our group that was not A. So those two groups, A and not A, they partner up to create the whole. So they're partnering up to create our sample space. To write this, we're going to write the complement of A is not A. Right? Other ways to write that, you could have A dash or even AC to represent that complement. So it's not quite as formal as the others, but it uses all those bits and pieces in it. So that's the main bits and pieces. We have a few little other things to look at. So one of the things that we can do is we're talking about those complementary events. We can write that as, so there's our P of not A. 1, now remembering that all probabilities are between 0 and 1, minus the probability of A. So that's a little bit of more formal notation for our complements. Okay, it's a little bit more of that formal notation. If we want to go A only, because we have that as an option in our probability sets, if it's A only, all right, so that is elements in group A or set A that do not belong anywhere else. Okay, so it doesn't belong anywhere else. We would write that as A intersection not B. So it has to be in A, but it can't be in B, in group B. Okay, so that's our A only formal notation. And then the last little bit, if I have n of A, that just represents the number of elements in group A. The number of elements in group A. So that's what we have there. You can see at the bottom of the screen, we have this that I've just moved up, version of a Venn diagram with a two-way table that is using all that formal notation. So you can see that in this little section here, where the 1 was, that's our intersection. Okay, we have our A only. Over here we have our B only, and then to match those up, here's our intersection again. Showing how many is in that group. So that's what the formal notation all looks like. In the next video, we'll go through an example.